Okay, we're finding out what it is meant by bivariate data and scatter plots. The objective is to determine the relationship between two numerical variables. Another numerical means they're numbers. So notice bivariate data shows the relationship between two variables. Bi meaning two, they're highlighted, and variate and variable. So it's going to show the relationship between two variables. The two sets of data we're going to compare, we'll use a table and a graph. Here's some examples of bivariate data. The number of ice cream cones sold is going to depend on the temperature outside. Students' a test grade is going to depend on the number of homeworks he or she completes. The height of the football above the ground depends on the time since the football's been kicked. And the number of Taylor Swift concert tickets sold is going to depend on the cost of each ticket. Remember, bivariate data may have a linear relationship, linear, line, right? Making a line. No relationship or relationship that is not linear. So we use scatter plots to graph the bivariate data. Remember, point X, a point on a graph, a coordinate plane has an X value and a Y value. We're going to take our points from our table. So if someone did 5 homeworks out of 10, they got a 70. So that's shown here in the table, and then if you go over to the graph, over 5, up 70. Now, remember, when you take data, you're never going to have an exactly perfect graph. This tends to have a linear relationship. Basically, as homework completed increases, the number of test scores increase. So note, here is the x-axis, it's horizontal, it's the independent variable, and it's the number of homeworks completed. Over here is the vertical axis. It's dependent because your test scores depend on how many homeworks you did. Test scores are affected by the number of homework completed. So test scores are dependent, while number of homework is independent because you can control that. You can control the number of homeworks you do. So let's look at another linear relationship. So you'll see these temperatures are in Celsius. So 14.2 is about 56. 22.1 is about 77 degrees, just so you get an idea of what the temperature is in Fahrenheit. Notice these independent values, they're just collecting data, and so they're not going to go up necessarily in ascending order, because one day it's going to be 56, the next day it could be 60, etc., etc. So you'll see, here's the scatter plot. It tends to have also a linear relationship. Not exactly a line, but we could draw what we call a line of best fit, which we'll talk about later in this section. Be careful though, what's missing from this y-axis? There's no label there. So you would want to have ice cream sales in dollars. It's very important that you label everything on your graph. So what would be the independent variable? What's the dependent? Does the amount of money I sell depend on the temperature? Or does the temperature depend on the amount of sales? Basically, the amount of ice cream I sell is going to depend on the temperature outside. So amount of money from ice cream sales is dependent because it depends on the temperature outside. Scatter plots. They can have a positive relationship or correlation. They can have a negative correlation, or they'll have no correlation. So this is positive correlation. It tends to be linear. The hours we sleep, as that increases, our test scores tend to increase also. So that's positive. Notice green. As independent variable increases, the dependent variable also increases. Well, what's negative look like? Well, it also tends to have somewhat of a linear relationship. But as the amount of time I spend training goes up, my time comes down, which is what you would hope. So that is a negative correlation because as the independent variable increases, the dependent variable decreases. Well, what's something, two variables that would have no relationship at all? That would be something that had no correlation. Notice there is no relationship between these two sets of data. The average time you spent watching TV in a week has nothing to do with the size of your television. So there's no correlation between these two variables. We're basically this year going to be doing a lot of linear equations and collect data that tends to be linear. However, a couple times we'll be collecting data that's not linear, but that still has a type of relationship. So this has a correlation, it's just not going to be linear. So notice, as time increases, when we punt a football, the height of the football goes up, but then it must come down. So this tends to be a quadratic relationship, which you'll talk about in algebra and we'll touch on a little this year. I just wanted to let you know that don't think that everything that we collect when we collect data is going to be linear. Here's another one that's not linear. Notice as the speed increases, the time it takes you to get from one place to the other is going to decrease. So this is more of a curve. As the speed increases, the time it takes decreases, but it's not very linear. It's more of a curved relationship. So it's a relationship that's nonlinear. This happens to be an inverse correlation, which we're going to talk about a little bit this year in this first section. So what I would like you to do now is your vocabulary words. They go in the vocabulary section of your notebook. You can go back. What is bivariate data? What's a scatter plot? What's a dependent variable? Independent variable? What does it mean to be linear? Linear is basically, if you look at just the first four letters of linear, it tends to be a line. Correlation? What does a positive correlation look like? What does negative correlation look like? To answer this question, will all bivariate data have a linear relationship? If not, I want you in your notebook to give an example of bivariate data that does not have a linear relationship. You are more than welcome to go back and look at your notes or look at this video. Also, give another example. You can use the one I used or try to come up with your own of bivariate data that will have no relationship. Remember, bivariate. We have two variables and we want to see how they're related. All right, we'll see you tomorrow. Please have everything complete so you can get together and do your experiment with your group. If you don't do this, you're going to have to forego the experiment and all the fun. See you tomorrow.